Plus, okay. Pay your attention, listen. Drinking water, stop drinking water. And okay, physical quantity is also classified as, previously we have classified physical quantity as fundamental and dry. So we have done with that one, and we have digested the topic pretty well. So today we are having another classification of physical quantity. So it is based on their magnitude and unit. So first let me explain any physical quantity. Any physical quantity is expressed by two things. For example, can you tell me your height or your weight?
My height, I think is 166.
No, your weight.
My weight, 45.
So the weight of Nako's weight is
49.5.
It's okay, 49 kilogram. Okay. Now pay your attention. So whenever I ask questions, pay your but pay your attention. Because today you spend additional time in the field, so I just need to be very fast, okay, to use that. Okay, so physical quantities, any physical quantity is expressed by these two things in additional parameters. So this, the weight of Nako is like 49 kilograms, so this 49 is called magnitude. We call it magnitude. Magnitude is just the amount. How much is Nako weight? It tells us the amount. And kg is the unit, exactly. So physical quantities are expressed by two things. The first is the magnitude, and the other is the unit. So if somebody asks, if I ask somebody, how much do you weigh? And you say, would you please? Last time I told you, whenever I made a statement, please don't ask me questions after I make a statement. Okay? So whenever I ask somebody, how much do you weigh? And he says 25 or whatever. It doesn't make sense. He should attach the unit as well. 25 pound, kilogram, whatever. Okay? So, physical quantity, they're expressed by their magnitude and their unit. So the magnitude tells us the numerical value, the amount, it is 49, and kilogram is the unit of measurement. It is measured in kilograms. It could have been in grams or in pounds. There are so many units that you can express any physical, U weight. So, the other example, you can tell me what time is it now, for example? The time?
Time it is
5:36. It's o'clock, right? So 5:36 is the magnitude, and actually it's 5 hour. This is hour, and so 6 is the minute, right? So let's say it is 5 hours. 5 o'clock. So 5 is the magnitude. Magnitude is simply the numerical value, and we attach a unit into measurement. How? Any other? Can you tell me how? You ladies.
1 meter and 66.
Yeah. 1 meter and 66. It's attached meter. 1 meter and 66 centimeters actually, so we usually use the unit. So 1.66 is the magnitude and meter is the unit measurement. So it's very important. So physical quantities, they are classified into two basic groups. So the first one, they are called scalar. Scalar physical quantities. Scalar physical quantities. And the second one are called vector physical quantities. Scalar physical quantities, they are expressed only by their magnitude and by their unit. Simple. Any scalar quantity is expressed only by their magnitude and unit. Or usually you can say that by their magnitude, because usually we know there is a unit in any physical quantity. So whenever I say any physical quantity that is expressed only by their magnitude, we call it scalar physical quantity. So they're expressed by their magnitude plus unit. In general, you can say it's magnitude. So examples of scalar physical quantity.
Length.
Length, very good. No, I just give me the name of the physical quantity in general. Time. Length time.
Kilograms?
So we call that the kilograms unit mass per unit. Length time, mass.
There's current and
Current has actually direction. So length, mass, time, and yes.
temperature.
Temperature, very good. And so on. So if, for example, if I say I'm 65 kilogram to the east, does it make sense? Listen first, listen. Don't say I don't like the word If you have a question, just raise your hands, okay? So if I say I weigh 65 kilogram to the east, does it make sense? No, it doesn't make sense, right? But if I'm pushing this wall to the east direction, does it make sense? With 40 Newton force, if I push this wall, 40 Newton force to the west, it does make sense, right? So my force is expressed as magnitude in units, but it has also what? Direction, right? So it takes us to the second physical quantity, vector. Vector physical quantity is expressed by
It has magnitude and
unit
direction.
and direction. So vector physical quantities are expressed not only by their magnitude and unit, but additionally they are expressed by their direction. They have direction. Previously, I gave you as an example that I'm 65 kilogram to the east. It doesn't make sense because mass is what quantity? Scalar physical quantity, and it cannot be expressed by its direction, but by its magnitude and unit. Okay, so examples: vector physical quantity they are expressed by their magnitude plus unit plus direction. For example, force. For example, force. I'm pushing a force. I'm pushing this wall with force of 40 Newton to the
East, west, north, south.
Actually, to the west. Actually, let's take this as the west. This is the east. Okay. So, what is 40? Now, please participate. All of you participate with periodically. What is 40?
Magnitude.
Magnitude. What is Newton?
That's the unit.
The unit. What is west?
The direction.
The direction. Clear.
Clear.
Everything is clear, crystal clear. It should be. Because this is actually very fundamental concept. Because it takes you to the next level. We're not going to talk about vector and scalar, but we use this vector and scalar to take our lesson further. Okay, so another example, acceleration is also scalar, vector physical quantity. By the way, vector physical quantities, on the top of the quantities, we use arrows. We use arrow to show they have a direction as well. For example, if you are expressing the force, you have to add an arrow. For example, it's 40 Newton. East. If I say this arrow is mean the force is vector quantity, it has a direction as well. In acceleration, maybe give you an acceleration of a car to be 4 meters per second square due west. A car is accelerating. Actually, I have to add an arrow here. If a car is accelerating 40 meters per second square, that means the speed is changing at a rate of 40 meters per second square. So, no, I mean 4. So this 4 is meter per second and waist. Now you can tell me what is 4, what is meter per second squared, and what is waist. What is 4? 4 is the magnitude because it tells me the amount, it's the numerical value, and meter per second squared is the unit. What kind of unit is that? Derived or fundamental unit? Derived because it derived from the length and from the time, right? It's very clear. Is that clear? Yeah, okay. So waist is the direction. So, don't you be sleeping? Don't you be sleeping because I saw you just coming from the field. So this.
I'm not sleeping.
You like sleeping. You like fire. I'm not right, right? Am I right? Okay. So let me go to the acceleration. Let me give you an example of acceleration of a car.
Meters per second.
4 meters per second squared due east, we say. So 4 is the magnitude, meter per second is the unit. What kind of unit it is? Derived unit. Because it's derived from the unit of length, meter, the unit of what? Time, which is second square. Yeah, so, and we have east, which is the, to recap this lesson, and today's lesson, to revise, physical quantities are also expressed, or physical quantities are also classified into another 2 groups, namely scalar and vector physical. Scalar physical quantities, they are only expressed by their magnitude and by their unit. Length, time, mass, temperature, density, actually, and the like are called scalar physical quantities because it doesn't make sense even if you try to give them a direction. As I mentioned earlier, that my weight is 65 kilograms. If I add direction, then it doesn't make sense. But if I add a direction to my force, to my acceleration, to my velocity, then it does make sense because they can be expressed by their magnitude, unit, and direction. Is that clear? Okay. So let me give notes, then please take it as quick as possible. Yes. So far we have, listen. So far we have 2 groups of Telegram channel, A and B, and we have also 2 Google Classroom classes. So from now on we need to have additional, the 3rd one, the C, because you are now ABC. So when I attach class or homework, then please create one group of your own as a 7A.
Well, we already have that.
Yeah, but there are actually some students which are not. So have the new one, so when I touch classwork, then you can get it there.
And you're creating 7 A. It's like gigabytes, terabytes, are they physical quantities? Gigabytes, terabytes, are they physical quantities?
No, they can't be measured.
Yeah, they're measured. So are they external?
Actually, there are these terms belongs to the computer. I mean space. The space. I mean,
Space storage.
cheap space can be actually expressed in tera, mega, megabytes. So they're used for memory space actually.
Are they phosphorus?
So they just ones. Yeah, you can call them as so that basically in the context of computer science. So but take the mass. Quantity means like if you quantify the mass. Yeah, they're quantified. So you can call the mass. So they are units of tera or mega gigabytes of the memory space actually. Okay. Please take it very quickly because we spent like 15 minutes outside, so we have to compensate this one.
Yes. 15.
So, in the same way, you can also give example for names by yourself. For time, for temperature, and for days. You can give your own example to show that the numerical value is a magnitude and this symbol, for example, the kilogram is the unit. Okay? physical, but if you don't have, then I'll post it. I'll take the post it. So for the next class, I'll have to show.
Next class.
Next physics class.
It's not tomorrow, it's next class.
Yes, next class. So, you can give an example. So you do an example for length. You can take your height. Your height is maybe 1.65. So 1.65 is the magnitude, and meter is the unit. So you can give a sign for time, temperature, and density. Temperature, you can express this room temperature to be like 25 degrees Celsius, right? Room temperature, for example, room temperature of this room, the temperature of this room is 25 degrees Celsius. So 25 is the magnitude, degrees Celsius is the unit of measurement. Density is actually expressed in kilogram per meter cube. So you have to add, because you have spent, as I told you, too much time on site. I need to be as quick as possible. That's why.
Can I go check the board?
What will be next to it, sir?
Can I go check the board? Can I go check the program? The program.
English and that. English and that.
I don't know.
And nothing to know.
No, I don't know.
What will be
Chemistry.
Chemistry comes in the album, rather than the file.
No, we don't know.
English.
English.
I'm coming. English.
So what are we doing here?
Okay, so if a car is accelerating at 6 meters per second squared due west, what is 6? 6 is the magnitude. It tells us how much, the amount, which is 6. Meter per second squared is the unit. What kind of unit is that? What kind of unit is that? Meter per second squared is what kind of unit? Drive unit, very good. Due west is the direction. Okay? So we have the magnitude, the unit, and the direction. This means acceleration is what quantity? Then acceleration is on top of being a derived physical quantity, acceleration is on top of being a derived physical quantity.
This is speed.
It's a vector.
It's a vector physical quantity. Yeah? Actually, we are on the context of vector and scalar, so it's very simple.
Oh, just search.
Yes, sir. You need to progress to acceleration of the sun. For example, the acceleration is meter per second. That's meter per second square. Okay.
been 32 minutes.
So that tomorrow we can take our English period at the center Rahel's period. But unfortunately she did not come early, so yes. Yeah. Okay. So let's see if we can manage I have a short lesson for us today about main and subordinate clauses. It's very short, and I'm sure most of you know what main and subordinate clauses are, right? So we're going to talk about that briefly and see if we can discuss. Tomorrow for our lesson and Miss Rahel's lesson, so that we have a double class for us to finish, to learn and finish also the presentation. So those who are not ready, finish up your presentation until tomorrow. Miss Rahel is going to take over the class, so that tomorrow we shall take her time for biology and the English time. It will be enough for us to learn and at the same time finish our presentation. Is that okay for everybody? Yes. Yeah? Yes. Okay, so see you tomorrow.
You have the exercise for biology?
Of course, yeah.
Always great. This is what I Miss, 35 minutes.